Okay, so we talked about different kinds of shapes. We overall, when we look at quadrilaterals, it's a shape that has four. It's a polygon with four sides. Today we're going to talk specifically not about these. Today we're going to talk specifically about a parallelogram. And to remind you, a parallelogram is a quadrilateral. We call it a parallelogram. It has four sides. Two pair of the sides are parallel. And we'll talk about the rest of it today. We'll prove the rest of this today. So we're talking about a parallelogram, which is a special kind of a quadrilateral. Here's the first thing that we'll remember is that the opposite sides of a parallelogram are congruent. So side BC is congruent to side AD, and side AB is congruent to side CD. And opposite angles of the parallelogram are congruent. And the diagonals of a parallelogram bisect each other. We're not going to explain why that works today. For right now, just remember that it happens. And we will work with more of that on Thursday. Now here's an interesting thing. If three or more parallel lines cut off congruent segments on one transversal, then, so here's the situation that you've got. We talked about transversals before, and when we're cut here, we know something about them. When our parallel lines are cut by a transversal, so these are the parallels, these are the transversal, we know that this one is congruent to this one. So if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. And because of this theorem, I know that BD is congruent to DF.